Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to proceed our syllabus with chapter 8. It is about the managing systems implementation. Under this topic, we have another 7 subtopics, okay? So we have the first one is the software quality assurance. Second, the overview of the application development. Third is the coding. Fourth is the testing of the system. Fifth, documentation. Sixth, training. And finally, about the data conversion. In this video, I'm going to cover only the first 3 subtopics. And therefore, in the end of this video, you are going to accomplish these 3 chapter objectives, which are the first one, you are going to explain the importance of software quality assurance and software engineering. The second one, you will be able to describe the application development using the structured, object-oriented, and also the agile method. And finally, number 3, you will be able to explain about the coding process. As an introduction, to manage system implementation, it involves the application development, testing, documentation, training, data conversion, system changeover, and also the post-implementation evaluation of the results. The system design specification serves as a blueprint for constructing the new system. The initial task is the application development, which requires the system analysts and programmers to work together to construct the necessary programs and code modules. The system must be tested and documented carefully, and users must be trained, and also the existing data must be converted. After the new system becomes operational, a formal evaluation of the result takes place as part of the final report to the management. Software quality assurance. In today's competitive business environment, companies are intensively concerned with the quality of their products and services. A successful organization must improve quality in every area, including its information system. Top management must provide the leadership, encouragement, and support needed for high-quality resources. Thus, rigorous testing catches errors in the implementation stage. However, it would be much less expensive to correct mistakes earlier in the development process. The main objective of quality assurance is to avoid problems or to identify them as soon as possible. Poor quality can result from inaccurate requirements, design problems, coding errors, faulty documentation, and also ineffective testing. To improve the finished product, software quality system developers should consider software engineering as well as the internationally recognized quality standards. Let's look at the first quality assurance part, which is the software engineering. An approach called the software engineering to manage and improve the quality of the finished system. So, a software engineering is actually a software development process that stresses the solid design, accurate documentation, and also careful testing. Therefore, Software Engineering Institute SEI at Carnegie Mellon University has designed 2 maturity models. The first one is CMM, which is the Capability Maturity Model, and also the CMMI, which is the Capability Maturity Model Integration, in order to improve the quality, reduce the development time, and also to cut the cost. So we can see here, this is the Capability Maturity Model Integration, CMMI, produced by SEI, where it has the 5 maturity level. Therefore, any software will be labeled by the maturity level. If the software is still unpredictable and reactive, so it will get the maturity level number 1. Okay, and then the stages, the maturity level becomes better when the numbering increase. Okay, so we can see here, the stable and flexible is the maturity level number 5. If that particular software development gets the maturity level number 5, according to the CMMI, basically the software is in its achievement level, the highest achievement level. Okay, the next one, we have the International Organization for Standardization, which is the ISO. So it is a worldwide body that establishes the quality standards for products and services. So if you can see here, the symbols and the logos, okay, on the right side, these are all the internationally standard. So we can see here, if the P symbol here referring to the international parking space. Okay, so as the envelope, the plus sign referring to the hospital, and etc. So basically, the ISO standard includes everything. Okay. In terms of the software development, many firms seek assurance that software systems will meet rigid quality standards. In 2004, ISO updated a set of guidelines called the ISO 9000-3-2004, which provided a quality assurance framework for developing and maintaining the software. So, using this framework, a company can specify the ISO standards when it purchases software from a supplier or using the ISO guideline for in-house software development in order to ensure that the final result measures up to the ISO standard. So we can see before this we are using the maturity level. We have the indexing. Level 1 is the poor, and then the level 5 is the optimized level or optimized indexing. However, for the ISO, they have this standardized framework. If any of the companies who develop the system and pass this framework, it means that the system is in optimized quality and ready to be launched. Okay, next we go to the overview of application development. So basically for this subtopic, it is just a revision because some of it already being familiar with you. Okay. So first we look into the overview of the application development. So application development is actually the process of constructing the programs and code modules that serve as the building blocks of the information system. And we have these 3 popular development options. The first one is the structured analysis, the second one is the object-oriented, and the third one is the agile method. And its main objective is to translate the design into program and code modules that will function properly. Okay. And this application development is basically divided into 2 methods. Either it is the traditional method or the agile method. So for the traditional method, basically we are playing with the modules. So the module consists of related program code organized into small units that are easy to understand and also to maintain. So when you create program modules using structured or object-oriented methods, you start by reviewing the documentation from the prior SDLC phases and you create a set of program designs. The centerpiece of your documentation is the system design specification accompanied by the diagrams, source documents, screen layout, report designs, data dictionary entries, and also the user comments. And at this point, the coding and testing tasks begin. So we can see here, these are the main steps in the application development where you can see here the development part. You can see all the modules, design modules, code modules, test module, and also the document modules. And after developing all the modules, they will perform the testing, okay, which we will cover later on the second video. Alright, contrast to the traditional method, the agile method is more towards the intense communication and collaboration between the IT team and also the users or the customer. The objective is to create the system through an iterative process of planning, design, coding, and also testing. So we have several models under the agile method. Okay, we have the spiral model, or also we have the extreme programming, which is the XP. So we can see here, this is the extreme programming project, and you can see here it is all about the iteration. Okay, it has been going forward and then it goes backward and then forward again and then backward again according to the user's needs, because of you have the intense communication and also the collaboration. Okay, the next part, we go to the system development tools. So basically, listed under the system development tools, we have the ER diagrams, which you have already learned last semester during the ITS 232 subject. And then you have the flowchart, you have the pseudocode, and finally the decision tables and also the decision trees. For the ER diagrams, it shows the interaction among the system entities and objects. So when it states here the interaction, it means the relationship one-to-one, one-to-many, and also many-to-many. Alright? The flowchart, on the other hand, shows the logical rules and interaction graphically using a series of symbols connected by the arrows. So if you can refresh your memory during your CSC 118 subjects, okay, so everything will be done graphic. So you have the oval sign, you have the parallelogram, you have the diamond symbol, and etc. Okay, the third tools is the pseudocode. Okay, you can see here, pseudocode is a combination of English as well as the computer code. So you can see here, the keyword if and also the keyword else is the computer code, where else, okay, the situation, okay, or the scenario, customer is a preferred customer, customer orders more than 1,000, you can use the plain English, our everyday English. Okay, the fourth tools is the decision tables and decision tree. And because of the word is decision, basically it involves Y for yes and also N for no. Okay, so analysts and also programmers can use the decision tables and trees during the system development as they develop code modules that implement the logical rules. So for example here, the scenario or the situation is either this customer is a preferred customer. If it is yes, is this preferred customer ordered more than 1,000? If it is yes, means is he or she use your charge card? If it is yes, it will get 5% discount plus the additional 5 discount because of its loyalty and because of the flow dah ditetapkan begitulah. Okay. And if it is no, it will have different situation and also different formula applied if the condition forwards to no. And finally, we have the coding. Okay, I do not think I have to explain more about coding because you already knew about the coding process, which is a process of turning the program logic into the specific instruction that the computer can execute. So basically, you are turning your pseudocode into your code modules. You are turning your decision trees and decision tables into the program codes, okay? So working from a specific design, a programmer may uses a programming language to transform program logic into the code segments. So usually for individual programmer, they might create a small program, while larger programs typically are provided into modules that several individuals or groups can work on simultaneously. Okay, and then we have the programming environments, okay. So basically, each IT department has its own programming environments and standards. Visual Basic, Python, Ruby, and SQL are examples of commonly used programming language. And then as the trend towards internet-based application that continues, HTML, Java, and other web-centric languages are used extensively. And for the programming environment, we have the Integrated Development Environment, IDE, where the programmer can simplify the integration of system components and reduce the code development time. IDEs can make it easier to program interactive software products by providing built-in tools and advanced features such as real-time error detection, syntax hints, highlighted code, class browsers, and also the version control. And finally, about the generating codes, some commercial applications can generate editable program code directly from macros, keystroke, or the mouse action. So that is our end of part 1. I will see you on the next video about the management of system implementation part 2. Thank you very much.